आपण अल्डिहाइड्स अँड कीटोन या टॉपिकचं डिस्कशन आपण करतो आहोत आणि यामध्ये काही महत्वाच्या रिॲक्शन्स आपण स्टडी करतो आहोत. द रिॲक्शन्स शोन बाय अल्डिहाइड्स अँड कीटोन. Already we have studied. First one is the aldol condensation and second is the Perkin reaction. या दोन्ही रिॲक्शन्स आपण डिटेल मध्ये डिस्कस केलेल्या होत्या. Now what is mean by aldol condensation? Suppose aldehyde or ketone which having alpha hydrogen atom, when it reacted with any base, suppose it is warm with alkali NaOH or KOH. Now two molecules of aldehyde undergo condensation. The two molecules of acetaldehyde participate in the reaction. They undergo condensation and we get the corresponding beta hydroxyaldehyde or beta hydroxyketone, and this reaction is called aldol condensation. Second one is the Perkin reaction. This reaction is shown by aromatic aldehyde. When this benzaldehyde, example of aromatic aldehyde, is treated with acetic anhydride, reaction is carried out in presence of sodium or potassium salt of acid. Okay, and that two molecules undergo condensation and we get the corresponding alpha beta unsaturated acid, and this reaction is called Perkin reaction. These are important reactions shown by carbonyl compounds. Now let us see next, again very important reaction shown by that carbonyl compound, and this is nothing but the Knoevenagel reaction. पण यामध्ये एक महत्वाची टर्म मी पहिल्यांदा एक्सप्लेन करतो आणि मग आपण जाऊया टुवर्ड्स Knoevenagel reaction. Okay, what is mean by active methylene compound? Let us see example. Diethyl, actually this is not methyl, diethyl malonate. Okay, this compound is a diethyl malonate. Here this is the CH2 group, methylene group, and the methylene group जो आहे, it is attached from one side by COOC2H5, that is ester, and from another side also by ester group. And this is example of active methylene compound. Now what is mean by active methylene group? Here CH2 is the methylene group, and if that CH2 is attached from both sides by electron withdrawing group, then that compounds are active methylene compounds. Actually that methylene group becomes active. That hydrogen atoms of methylene group, they becomes acidic in nature. That means that compound can lose that hydrogen atom easily. Therefore that hydrogens are acidic in nature, and such compound is called active methylene compound. Now question arises, actually which groups are electron withdrawing? कोणते group electron withdrawing groups आहेत? Consider example. Ester, COOC2H5 is example of electron withdrawing group. Then COOH, cyano group, then keto group, aldehyde. These are the examples of electron withdrawing group. And if such groups are attached to the methylene, then that compound is called active methylene compound. Consider another example. This is ethyl cyanoacetate. Here also that CH2 methylene group is attached from one side by cyano group, from another side by ester group, means it is attached from both sides by electron withdrawing group. Therefore it is example of again active methylene compound. Well-known example of active methylene compound. Consider another example. Here also this is CH2 methylene group. It having one ester and another is the ketone group. One is the ester and another is the ketone, means both are electron withdrawing, and hence again that methylene is active in nature, and that compound is an active methylene compound. Let us see one more example. CH2COOH. This is malonic acid. Again example of active methylene compound. Malonic acid is the example of active methylene compound. Okay, these are the some examples of active methylene compound, and these compounds having great application in our synthetic organic chemistry. कारण हे compounds active आहेत आणि म्हणून इतर ऑर्गॅनिक कंपाऊंड तयार करण्याकरिता या कंपाऊंडचा मोठ्या प्रमाणात यूज केला जातो, and therefore they are synthetically important compounds. Okay, now let us see what is exactly Knoevenagel reaction. आता आपण आपल्या रिएक्शन कडे येऊया. Okay, here we are using simple example of aldehyde. Suppose this is C6H5CHO. C6H5 means there is a benzene ring. There is a benzene ring. Instead of writing whole benzene ring, simply we can mention C6H5. That means there is a phenyl group. When this benzaldehyde is treated with active methylene compound. Okay, this is example of active methylene compound. The name of compound is diethyl malonate. Now this reaction is carried out in presence of base. R3N means it is tertiary amine. We can use any base, tertiary amine, or sometimes there may be use of directly alkali, NaOH, KOH. We can use sodium ethoxide. ओके, तर कोणताही बेस आपण या ठिकाणी यूज करतोय. अल्डिहाइड याची रिएक्शन आपण ऍक्टिव्ह मिथिलीन कंपाऊंड बरोबर करतोय डायइथिल मॅनोनेट बरोबर इन प्रेझेन्स ऑफ बेस. दॅट टू मॉलिक्युल्स मीन्स अल्डिहाइड and this active methylene compound they undergo condensation. तर दोन्हीचं कंडेन्सेशन होतं. सिंपली आपण काय म्हणूया, सपोज दॅट ऑक्सिजन फ्रॉम द अल्डिहाइड अँड दॅट टू हायड्रोजन ॲटम फ्रॉम द मिथिलीन, यामध्ये 2 हायड्रोजन आणि ऑक्सिजन H2O बाहेर पडेल. सो देर इज अ लॉस ऑफ H2O. मग इथला कार्बन आणि यामधला कार्बन यामध्ये डबल बॉन्ड या ठिकाणी तयार होतोय. दॅट टू मॉलिक्युल्स कंडेन्स टुगेदर अँड देर इज फॉर्मेशन ऑफ सच कंपाऊंड. विथ दिस कंपाऊंड फर्दर ऑन हायड्रॉलिसिस, त्याचा आपण हायड्रॉलिसिस करतो आहोत, फॉलोड बाय हिटिंग, आणि पुन्हा हिटिंग करतोय. पहिल्यांदा बघूया व्हॉट हॅपन्स व्हेन दॅट इंटरमिडिएट इज हायड्रोलाइज. ऍक्च्युअली विच आर द हायड्रोलायझेबल ग्रुप. या इंटरमिडिएट मध्ये कोणते ग्रुप आहेत की ज्याचा हायड्रोलायसिस होऊ शकतं. Here it having ester group, first one and second. Means that two ester group can be undergo hydrolysis. त्याचं हायड्रोलिसिस होऊ शकतं. म्हणजे we know that ester on hydrolysis gives carboxylic acid and then that compound is strongly heated. आपण जर त्या कंपाऊंडला स्ट्रॉंग हीट दिलं, it undergo limited decarboxylation. त्यामध्ये decarboxylation होतं. One carbon having 2 COOH group. One carbon having 2 COOH group. Out of that 2, 1 COOH undergo decarboxylation. Means there is a loss of carbon dioxide. यामधून CO2 बाहेर पडतो. हा कार्बन CO2 I have shown minus CO2 on the arrow. मग हा हायड्रोजन डायरेक्टली इथं कार्बनला अटॅच होतो and we get the product of C6H5CH, C6H5CH, double bond CH, and there is only 1 COOH. Okay, this is synamic. Actually how that process occur हे आपण मेकॅनिझम मध्ये डिटेल मध्ये डिस्कस करणार आहोत. and we get the alpha beta unsaturated acid. Name of the particular compound is a cinnamic acid. This is cinnamic acid, and thus we get cinnamic acid as a final product, and that reaction is called Knoevenagel reaction. This is well-known reaction having wide application in synthetic organic chemistry. Now let us see one more example regarding the same reaction. Okay, I will take simple example, acetaldehyde. When that acetaldehyde is treated with the same active methylene compound, CH2COO-C2H5, COO-C2H5, this is again diethyl malonate. Now what happens here? Here also that reaction is carried out in presence of strong base, suppose. Okay, now here that 2 molecules undergo condensation. Similar to benzaldehyde, here also that 2 molecules undergo condensation. Oxygen from acetaldehyde, 2 hydrogen atoms from that active methylene group, it form H2O. Then that 2 molecules condense together. There is a formation of unsaturated compound having 2 ester group. Now this diester compound intermediate further allowed to hydrolyze and followed by strong heating undergo decarboxylation. Here also in first step both the ester converts into COOH. यामध्ये सुद्धा दोन्ही ester पहिल्यांदा COOH मध्ये कन्वर्ट होतात आणि त्यामधल्या एकाचं डिकार्बोक्सिलेशन होतं and we get the corresponding alpha beta unsaturated acid CH3CH double bond CH COOH, and this is nothing but the crotonic acid. Okay, and thus we can synthesize alpha beta unsaturated carboxylic acid by using this Knoevenagel reaction. Here aldehydes, generally that reaction is shown by aromatic aldehyde. This reaction is generally shown by aromatic aldehyde, but in some case, suppose we have used a strong base, then that aliphatic aldehyde also undergo Knoevenagel reaction and we get the corresponding alpha beta unsaturated carboxylic acid. Okay, this is the general reaction. Now let us see the mechanism. But mechanism बघूया how actually that reaction takes place. Okay, let us see mechanism of the reaction, how that reaction takes place. Okay, this is our starting material. Diethyl malonate is the example of active methylene compound. Here there is CH2 group, COO-C2H5, COO-C2H5. I have shown that 1 hydrogen separately. Okay, now in first step we are using base. Suppose there is R3N tertiary amine, we are using base. What happens in first step? That base takes 1 hydrogen atom from the methylene group. या methylene group मधला एक hydrogen atom base घेतो. आपल्याला माहिती आहे that hydrogens are acidic in nature. That active methylene compound can lose that hydrogen easily. आणि base म्हणजे काय? तर tertiary amine having ability to take that hydrogen तो हायड्रोजन इझिली घेतो, H+ आयन घेतो. म्हणजेच इथं या ठिकाणी ही इलेक्ट्रॉन पेअर या हायड्रोजन बरोबर बॉन्ड तयार करतात आणि इथं तयार होईल R3NH आणि नायट्रोजनवर येतो पॉझिटिव्ह चार्ज. वाईल द बॉन्ड बिटवीन कार्बन अँड हायड्रोजन अंडरगो ब्रेकिंग, दॅट इलेक्ट्रॉन पेअर गोज टुवर्ड्स कार्बन, इट अक्वायर निगेटिव्ह चार्ज. त्यावरती निगेटिव्ह चार्ज येतो. म्हणजे इथं R3N आणि H म्हणजे पॉझिटिव्ह चार्ज दाखवतोय नायट्रोजन वरती. कॉन्जुगेट त्या ठिकाणी बेस तयार होतोय, कॉन्जुगेट ऍसिड तयार होतोय. त्याचबरोबर या ठिकाणी कार्बन वरती निगेटिव्ह चार्ज येतोय अँड दॅट स्पेसिस इज कॉल्ड कार्बॅनियन. अशा स्पेसिसला आपण कार्बॅनियन असं म्हणतोय. तस इन फर्स्ट स्टेप, base takes one hydrogen atom from the active methylene compound, from the diethyl malonate, and we get the carbanion. आपल्याला मिळतोय carbanion. Now let us see the second step. Okay, this is the carbanion which is formed in the first step. Now this carbanion act as a nucleophile. तो nucleophile म्हणून act होतो and it attack on the carbonyl compound. Suppose we are using benzaldehyde. Now here, this is the nucleophilic addition. This is the nucleophilic addition that carbanion attack on the benzaldehyde. It attack on the carbonyl carbon. म्हणजेच या दोन कार्बन मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. There is इलेक्ट्रॉन पेअर आहे. ही इलेक्ट्रॉन पेअर या दोन कार्बनच्या मध्ये नवीन बॉन्डचं फॉर्मेशन करतं. मग इथं जर नवीन बॉन्ड तयार होत असेल तर टू मेंटेन द बॅलन्सी ऑफ दिस कार्बन, one of the pi bond undergo breaking and this electron pair goes towards oxygen. ही इलेक्ट्रॉन पेअर ऑक्सिजन कडे जाते. इट अक्वायर्स निगेटिव्ह चार्ज. म्हणजे या दोन कार्बनच्या मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. इथला पाय बॉन्ड ब्रेक होतो and electron pair goes towards oxygen and it acquires negative charge and we get the intermediate. Suppose this is the negative charge on the oxygen. Okay, this is the new bond between two carbon. हा नवीन बॉन्ड तयार होतोय आणि आपल्याला मिळतोय अल्कोऑक्साइड आयन. This is second step. Okay, I will revise once again. What is the first step? In first step, tertiary amine base takes one hydrogen atom from the active methylene group. Then there is a formation of carbanion. We get the carbanion. In second step, that carbanion attack on the benzaldehyde. It attack on the carbonyl carbon and we get the alkoxide intermediate. Okay, now let us see the third step. Okay, this is our alkoxide intermediate. Now this alkoxide intermediate further takes proton from the conjugate acid. म्हणजे इथला O- आणि यामधला H+, there is a formation of OH group. We get the corresponding hydroxy compound. But this hydroxy compound easily undergo dehydration. त्याचं डिहायड्रेशन होतं. How it undergo dehydration? It loses water molecule. OH from one carbon, hydrogen from adjacent carbon is removed as a water molecule. म्हणजे H2 बाहेर पडतो and double bond appears in between that two carbon. दोन्हीच्या मध्ये डबल बॉन्ड येतो and we get the unsaturated compound. Okay, this is the double bond between two carbon. This is dehydration actually. Now this unsaturated compound having two ester group and it on acid hydrolysis. त्याचं जर आपण हायड्रॉलिसिस केलं, both the ester group are undergo hydrolysis. दोन्हीचे हायड्रॉलिसिस होतं and they converts into COOH आणि त्यांचं कन्व्हर्जन होतं COOH मध्ये and we get the dicarboxylic acid आणि आपल्याला मिळतो डायकार्बोक्सिलिक ऍसिड. That compound is a quite unstable. थोडासा अनस्टेबल आहे because one carbon having two COOH. मग यामध्ये काय होतं? One of the COOH undergo decarboxylation. म्हणजे यामधून CO2 बाहेर पडतो. I have written -CO2 on the arrow. एक CO2 बाहेर पडतो. हा जो हायड्रोजन आहे it directly attached to carbon. मग एक COOH remains as it is. One COOH remains as it is. Okay, and we get the compound C6H5 CH double bond CH and single bond COOH, and thus there is a formation of alpha beta unsaturated carboxylic acid. This is nothing but the cinnamic acid, and we have studied mechanism for the reaction. आपण या रिएक्शनचा मेकॅनिझम या ठिकाणी स्टडी केलेला आहे. मेकॅनिझम मध्ये आपण काय बघितलेलं आहे तर how actually formation of that alpha beta unsaturated acid. Okay, this is just about the mechanism of Knoevenagel condensation. आणि ऑर्गॅनिक केमिस्ट्री मध्ये या रिएक्शनचा खूप मोठ्या प्रमाणात यूज केला जातो, पर्टिक्युलरली इन सिंथेटिक ऑर्गॅनिक केमिस्ट्री फॉर द प्रिपरेशन ऑफ सो मेनी अदर ऑर्गॅनिक कंपाऊंड. आणि म्हणून ही रिएक्शन एक वेल नोन नेम रिएक्शन आहे आणि याचा यूज खूप मोठ्या प्रमाणात, आता याच्यामध्ये खूप मोठ्या प्रमाणात रिसर्च सुद्धा या रिएक्शन वरती झालेला आहे. म्हणजे वेगवेगळे कॅटलिस्ट आपण वापरू शकतो, वेगवेगळे अल्डिहाइड्स यूज केलेले आहेत किंवा वेगवेगळे ऍक्टिव्ह मिथिलीन कंपाऊंड्स त्यामध्ये यूज केलेले आहेत. वेगवेगळ्या कंडिशनला ही रिएक्शन कॅरी आउट करून पाहिलेली आहे. Okay, this is just about the Knoevenagel reaction.